So when thinking about functions, it's always important to know some of the motivation for why we use functions. And I have this short list. There's many reasons to use functions, but here's a few. One is that functions can return data to us. And we'll see what that looks like in some computations shortly. The second is that they help modularize and clean our code up. So from our previous example, we saw how we could eliminate a lot of lines of code and sort of move that functionality to a different part of the program and not have to worry about it. So our main in our previous program was only one line of code as opposed to 10. And that really helps when we're analyzing programs or reading other people's code. The third is functions can be shared with friends or anyone in the world. And that's a really important part of computer science because that saves everyone time. You'll notice that we've always included these libraries, and these libraries consist of functions. So we've been using someone else's IOStream library to do input and output, for example. Reason number 4 sort of goes with reason number 1, but they can be composed to do greater things. That is, we can make use of functionality from one function and then use that result to compute another, and so forth and so on. Number 4 is really important, and we'll look at that in later lessons when we talk about lambdas and start creating functions that call other functions as well. And of course, number 5, functions are fun. All right, number 5 is a little bit of a joke. But functions, when we think about them, we're actually quite familiar with them from our trigonometry days. We have functions like cosine, which takes in a parameter, some real number, and it returns a value. And it's important to note when I say a function returns a value, that's the one here. That's the result of the function executing. Not necessarily text output to our terminal. The text is output, but the difference is that the return value is specified by our return type. Okay, so let's write a function to make that more clear. So for this function, I'm going to write, it's going to be for square. So as an example, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, and so on. So the function's name is going to be square. It's going to take in an integer, and I'm just going to call this the value that's being input, because in this case the value is going to be something like 2, 3, 4, and so on. And then I'm going to create the code block. This is where we're going to actually do the work. From square, we want to return a value. From our previous function, it was okay to just output some result here, some text to the screen. But I actually want to return a value that matches and is an integer from this function so we can make use of it later. So in order to do that, there's a C++ keyword, return. And then a value will be here that we want to return. And we can only return one value from a function, at least for now. Okay, so what we want to do is I'm going to separate this out, and our result of the square function is going to be value times value. So for example, if our value that we're passing in the square function is 2, then this will be 2 times 2. And that'll be stored in result, and we'll return the result. Now we're missing one thing, and that's the return type. And the return type needs to match the return keyword here. So this return is returning a result, which is an integer. So we do that by putting the data type that we want to return in front of square, just like this. So int square. And that's our square function. So let's test it out. So in order to use this function, it's square, and we'll put in an integer to test that it works too, and we're expecting a result. It will return a value of 4. Now in order to return this result, we need to do something with it. So we have two options. We can store it in a variable. I'm going to call it square of 2 equals this. Or we can just output the result as such and print it out. Okay. And I'm also going to output what's in this variable so we can see it's the same thing. Alright, so this is our function call, square of 2, and this is the value square of 2. And it's going to output square of 2, what's held in that variable. Okay, let's run this program. No errors, great. We run. Square of 2 is 4. Square of 2 is 4. Great. And we can make this output a little nicer by putting in maybe a colon and a space here. And run one more time. Okay, same result. So now we've seen what the square of 2 is. Now, to see what the power of functions are, let's go ahead and compute the squares of the first 100 numbers. Something that if we had to do manually, it would be really tedious to go through and say do 5 times 5 equals 25, 6 times 6 equals 36, and so on. You might have had to do this in elementary school, but you never will anymore because we're computer scientists now and we can automate this. Okay, so I'm going to just clean up some of this code here. And what's a tool that we can use to output everything? Well, we can use our loops to do this. A for loop, perhaps. So for int I equals 0, I'm going to say, well, I is less than 100, because we want the first 100 squares, plus I. And we're going to output the result. I'm going to put I here, so we know what square we're computing. And then output a space. So we have a nice pretty print. And then our equation, square. And we're passing as a parameter I. Okay? And so the I, remember, is what's from this for loop. So I is incrementing every time here. And we're calling our function square on 0. Call it square of 1, square of 2, square of 3, and so on. Let's try to compile and run this program. Alright, got a lot of results, and let's scroll to the top as a sanity check. Okay, so square of 0 is 0, 1 times 1 is 1, 2 times 2 is 4, square of 3 is 9, square of 4 is 16, 25, 36, square of 7, 49, and so on. Looks like our program's working correctly. So now we've just seen how we can use functions to really start doing some work for us. And now, though, I'm going to pose some more functionality that we can use with functions to make them more powerful. But a few quick notes on functions. So we've seen that the return type is important, and that int must return the return type of result. And what's result? Result's an integer, as defined in line 9 here. Functions themselves can have one parameter. They could have more parameters. In fact, they could have as many as we want. Or they could have 0 parameters if we just want to do some work. For example, for square, we need 1 parameter, but we could write another function with no parameters and just says hello. And let's go ahead and put this in our loop just to demonstrate a function that's not returning anything. So notice no return statement, so the return type's void, but we can call it just as regular. So we're going to see every square and then a hello interleaved here. Compile, run, and hello. So now our program's a little bit silly, but we've seen a few examples of functions. Okay, thanks.